1.2.1, the periodic table. You've got to know how in the modern periodic table, now the one that you look at, especially the one you get at your GCSE or the one you get in front of you for your mock exams, the elements are arranged in atomic number order. We now know that every different element has a different number of protons, so we can arrange them in that order. Remember from the previous periodic table, for Mendeleev's periodic table and before Mendeleev, that they arranged it in the information they knew. So they went for atomic mass order. But you've got to remember that the elements in the periodic table are arranged in atomic number order. Now, when we're looking for patterns and trends, we've now discovered in our modern periodic table that elements with similar properties are in the same column. Now, we call them groups. Elements in the same group have similar chemical properties because they have the same number of outer shell electrons. Do you remember that phrase? Outer shell electrons. So for instance, elements in group 1 all have 1 electron in their outer shell. So lithium is electron arrangement 2.1, sodium 2.8.1, potassium 2.8.8.1. They all have 1 outer shell electron, so they share similar chemical properties. Likewise, the elements in group 7, the halogens, they have similar number of outer shell electrons. Fluorine 2.7, chlorine 2.8.7. After that, it gets a little bit more complicated in terms of the number in the outer shell, but you just need to remember that all of the elements in group 7 need to gain 1 electron to have a full outer shell, so therefore they have similar chemical properties. Then if we consider group 0, the noble gases, we've got to look at them as a rare breed of elements. They can exist on their own. They don't need to form bonds with other atoms to be stable. That's because they have a stable electron arrangement. In other words, the outer shell is full. That means they don't have to form a chemical bond to become stable. So for instance, helium 2.0, neon 2.8.0, argon 2.8.8.0. They all have a stable electron arrangement, SEA, stable electron arrangement. I once went out with a group of noble gases and someone came over and picked on them. And I was like, why didn't you say anything? And they looked at each other and said, we're noble gases, we don't react. We will go on and look at group 1, group 7 and group 0 in more detail. So just for now, make sure you've got the point. The elements with similar number of outer shell electrons will be in the same group because they have similar chemical properties.